Okay, girls, today we're going to look at independent events. So still on probability, looking at independent events. So here we're kind of looking at what would happen if we do two things at once. So here we are rolling a dice and spinning a spinner at the same time. And so you will get a number from the dice and a colour from the spinner. What is the probability that the dice shows an even number, that the spinner lands on red, or that the dice shows an even number and the spinner lands on red? Okay, so the first two questions should be nice and straightforward. So an even number, there are 3 even numbers on a dice, 2, 4 and 6. So the probability is, there are 3, did I say 3? I don't know. There are 3 even numbers on a dice, so 3 out of 6, which is a half, which is the probability that you get an even number. For the spinner, there is 1 section on the spinner which is red out of 3 sections altogether, so the probability that it lands on red is 1 out of 3. And then for the probability that it shows, the dice shows an even number and the spinner lands on red, we need to look at all the different combinations of things that can happen. For this, we use this kind of table, which we call a sample space diagram. So you can see you've got the dice, the numbers that can come up on the dice along the top of the table, and then you've got the things that can happen on the spinner along the side. And then inside the table, so all of these are what can happen at the same time. So you can get red on the spinner and 1 on the dice. You can get red on the spinner and 2 on the dice. You can get blue on the spinner and 5 on the dice, which would be this one here. So it gives you an idea of how many different outcomes there are altogether. So there's 3 things on the spinner, 6 things on the dice. 3 times 6 is 18. So there are 18 different combinations that you can get when you spin the spinner and roll the dice at the same time. The probability that you get an even number and a red on the spinner, so you could get R2, R4 and R6, because they're all red and they're all your even numbers on the dice. So that's 3 successful outcomes out of 18 outcomes altogether. So 3 out of 18, which is 1 over 6. If we go back and look at the probabilities we had for the 2 things separately, so dice having an even number was a half, and getting a red on the spinner was a third. We can hopefully see that when you multiply those 2 fractions together, you get 1 over 6. So the probability that the dice is even and the spinner is red, we can work out by multiplying together the 2, the individual probabilities. This is called the AND rule. So we're going even number and spinner red, and to work that out, we can multiply together the 2 individual probabilities. I hope that makes sense. So independent events are events where the outcome of one doesn't affect the outcome of the other. So things like, have they got an example? No. So things like, I don't know, waking up at 8 a.m. tomorrow morning and having blonde hair. Yeah, those 2 things are completely independent of each other. Neither affects the other. You can getting up at 8 doesn't make your hair blonde, and having blonde hair doesn't necessarily mean that you get up at 8 o'clock in the morning. Those 2 things are completely independent. One does not have any impact on the other whatsoever. So if 2 events are independent, the probability that both things happen is the probability of the first thing multiplied by the probability of the second thing. So again, that's kind of your AND rule. So rolling a dice and spinning a spinner, they are 2 independent events. Whatever you get on the dice doesn't affect what happens with the spinner. So what is the probability the dice shows an odd number, probability the spinner lands on blue, and then the probability that the dice shows an odd number and the spinner lands on blue. So we need to work out the 2 individual probabilities first, and then we can multiply them together to answer part C. So odd number, there are 3 odd numbers on your dice, 1, 3 and 5. So the probability that the dice gives an odd number is 3 out of 6, which is a half, same as an even number. And then for the spinner, what was it? The probability that the spinner lands on blue. There are 3 blue sections on the dice out of 5 sections altogether. So 3 over 5, and we can't simplify that. It just stays as it is. And then to work out the probability that we get an odd number on the dice and blue on the spinner, we would multiply those 2 fractions together. So we do a half multiplied by 3 over 5. Multiplying fractions is nice and easy. We multiply the top together, multiply the bottom together. So 1 times 3 is 3, 2 times 5 is 10, so the probability is 3 out of 10. Okay, again, you could have done it by looking at it in a sample space diagram. There would have been 30 different outcomes or different combinations of the numbers on the dice and the colours on the spinner. There'd be 30 different combinations, but yeah, a quicker way is just to multiply the individual probabilities together. So 3 over 10. I don't know why this is coming up in the wrong order. Anyway, the probability that an event A occurs is 0.3 and the probability that an event B occurs is 0.2. They are independent, so one doesn't have any impact on the other. What is the probability that they both occur? We just multiply the probabilities together. So we do 0.3 times 0.2, which is 0.06. Okay, really, really straightforward. It's important that they are independent. It becomes a bit more complicated if they're not, but for today we're only concentrating on independent events, so you can just multiply those 2 things together. In a game, you pick a card, replace it. Again, it's only important that we replace it so that the probabilities stay the same. And then we pick again. Rosie wins if both cards are even. Eva wins if both cards are odd. Dora wins if the cards are different. Is the game fair? So to work this out, we need to work out the probability that each of them have of winning. So probability that Rosie wins is the probability that the first card is even multiplied by the probability that the second card is even. There are 2 even cards out of 4 cards altogether, so the probability of an even card is a half, and that's repeated twice, so we multiply it by itself, or we square it. So the probability that Rosie wins is 1 over 4. For Eva, there are 2 odd cards as well, so the probability of getting an odd card is still 1 over 2, because there's 2 out of 4, which is a half. So we multiply it by itself again, which again gives us the quarter. So far, so good. It seems pretty fair. They both have the same chance of winning. Dora, now again, what they've used here is the probability that, is the idea that all probabilities have to add up to 1. So when they play the game, those are the only things that can happen. Rosie can win, Eva can win, or Dora can win. So those 3 probabilities have to add up to make 1. So to work out the probability of Dora winning, we can do 1 subtract the 2 probabilities of Rosie and Eva. So that's 1 minus a quarter plus a quarter. So that's 1 minus a half, which is a half. So that means Dora has more chance of winning than Rosie and Eva. So it's probably not a fair game. She has double the chance of winning than they do. If you were to work that out without doing 1 minus, the probability that they're different that's the easiest way to do it. To work out the probability that they're both different gets a little bit more complicated. So because there's 2 different ways it could happen, you could get odd then even then odd. Just do it by doing the 1 subtract the probabilities that you know, which is a half. Okay, again, have a go at the tasks in the slides, please, and submit what you've done by the end of the lesson. Have a lovely day, girls. Thank you.